In this video, I will be giving a brief introduction on the web and HTTP. HTTP is the web's application layer protocol and is short for Hypertext Transfer Protocol. It is the main way that clients and servers that execute on different ends use to communicate with each other through the internet. HTTP messages include information such as to whom the message should be sent, from whom the message was sent, what actions should be taken, data, and many more. In this way, electronic mails, photos, videos can all be sent through the internet when the users demand them. HTTP applies TCP as its transport protocol. By using TCP, HTTP does not have to worry that data might be lost while transferring through the internet. Web browsers serve as the client side of HTTP, and web servers work as the server side, storing web objects that are addressable by URLs. When clients demand web objects from the server, it first initiates a TCP connection with the server. The server then sends an acknowledgement back to the client. The client acknowledges back again along with a request message that asks the server for files or to perform other actions. Finally, the server transmits the data requested back to the client. Since the HTTP server stores no information about the clients, the HTTP is a stateless protocol. When a client asks for a web page from the server, the web page might consist of many web objects. The server could send the web objects from the same TCP connection or through different connections every time it sends a web object. The former is called persistent connection while the latter is called non-persistent connection. Persistent connections are used as default in HTTP. If non-persistent connection is applied, a new TCP connection will have to be formed every time the client asks for a web object. And due to the time needed to initiate the connection and send acknowledgement, it would waste a lot of time if non-persistent connections were to be used compared to persistent connections. Parallel TCP connections can also be applied to speed up the process of sending data. Since the data being transferred are now transmitted through many TCP connections in parallel, the response time can be shortened. There are two types of HTTP messages. One is the request message and the other is the response message. The request message contains a request line, some header lines, and the entity body. The request line can be further divided into three parts: method, URL, and version. The method field could be of different values, such as get, post, head, put, and delete, with get being the most frequently used method. It is used when the client requests a web object, with the web object further specified in the URL field. And the version indicates the version of the HTTP implemented. In the figure below, the first command line applying telnet is used to initiate a connection between the client and the server. After connecting to the server, a simple request message is transmitted. In the first line of the message, it can be seen that the client uses get in the method field, asking for a web object. The URL and version follows after the method field. The header lines contain two lines in this example. The first line specifies the host that stores the object requested. The second line means that the client does not want to apply the persistent connection method. It wishes for the server to close the connection after sending the requested object. After hitting the enter key 2 times, a response message is received from the server. A typical HTTP response message contains 3 parts: the status line, header lines, and the entity body. The status line can be further divided into 3 parts: version, status code, and phrase. In the example, the version of the HTTP used is HTTP 1.1. The phrase is associated with the status code, with the status code being 200 and OK being the associated phrase. This means that the request has succeeded and the information is included in the response. Other status code and phrases include 301 move permanently, which means that the requested object has been moved to another location, with the new location being specified in the location header line of the response message. 400 bad requests, which means that the request message could not be understood by the server. 404 not found, which means that the requested object does not exist on the server, and many more. The following several lines are the header lines in this response message. The date header line specifies the time that the HTTP response message was created and sent by the server. The server header line indicates the server that generated the response message. The XPowered by header line reveals more information about the web server and might be considered as a security vulnerability that exposes more information that would be otherwise more difficult to access. The content length header line shows the number of bytes in the object that is being sent. The connection close header line indicates that the server will close the connection after sending the web object. The content type header line shows that the object in the entity body is HTML text. Finally, a part of the entity body, which contains the requested object, is shown at the bottom. Although HTTP servers are stateless, there might be some reasons that the server will want to identify its users, either to restrict user access or to provide personalization services based on user identities. Thus, HTTP uses cookies as a way to achieve this objective. After a client sends a usual HTTP request message to the server will reply with the usual HTTP response message along with the setCookie header line that contains an identification number. When the client sees this header, it appends a line that contains the host name of the server and the identification number to the special cookie file it manages. Now, every time the client requests an object from the server, a cookie header line that contains the identification number is included in the HTTP request message, and the server will be able to track the activities that the client with this identification number had performed. In this case, the server host is eBay, and the identification number assigned to the user is 1205. If the client provides some personal information during these activities, the server can then store these information in its database and associate them with the corresponding identification number. As a result, the server can often learn a lot about clients through the use of cookies. Although many conveniences are provided to the users in this way, the use of cookies can also be considered as a privacy invasion problem that must be treated with care. A web cache, also known as a proxy server, can satisfy HTTP requests on behalf of an original web server. If browsers are configured so that all HTTP requests are first directed to the web cache, web traffic can be substantially reduced. When a client is requesting a web object, instead of establishing a TCP connection directly with the web server, it now initiates a TCP connection with the web cache. If the web cache finds that it has the requested object stored in its storage, the object is sent to the client within an HTTP response message and the process is finished. If the web cache does not have the object stored locally, it then establishes a TCP connection with the origin server and sends a HTTP request message asking for the object. The server replies with the object through an HTTP response message. When the web cache receives the object, it stores a copy in its storage and sends a copy to the original client through an HTTP response message. In the above situations, the web cache can act as a server when providing objects to the client browser, and can also act as a client when requesting the object from the web server. Web caches has two main benefits. The first one is the web cache can reduce the response time for a client request. If the web cache has the requested object stored locally, it could transmit it back to the client when the TCP connection is established. Since the connection between the client and the web cache is often high speed, and data will not have to be transmitted through a long distance as compared to the connections between clients and servers, by applying web caches, a substantial amount of time can be saved in this way. The other great benefit that the web cache provides is it can reduce traffic on an institution's access link to the internet. Institutions will not have to upgrade its bandwidth as frequently if the traffic is reduced. And also, web caches reduce traffic for the internet as a whole, improving performance for all applications. A main problem that arises due to the use of web caches is that the objects stored in the cache might not be up to date. Thus, the need of checking if there were updates for the object arises. The HTTP request message from the web cache to the origin server applies a mechanism called the conditional get by adding a if modified since header line, containing the time that the object has been last modified. This tells the server to only send the object if the object has been modified since the specified time. The server sends back a response message in either case, but if the object has not been modified, 304 not modified will be included as the status code and phrase in the status line, and the entity body will be left empty, saving bandwidth and reducing response time. HTTPS is short for Secure Hypertext Transfer Protocol and is not the protocol that most web browsers use. A main problem with the HTTP is that it is in clear text and can be easily read. This poses a privacy threat that a hacker that is listening in somewhere in the internet can read the messages that clients transmitted. Information such as names, addresses, and credit card numbers would all be vulnerable to these hackers if written in clear text. HTTPS solves this problem by encrypting the data before the messages are being transferred. By using encryption algorithms, now the data being transmitted through the internet are made to be impossible to read, and will provide no useful information even if listened in by hackers. For websites that require users to enter personal information, HTTPS will be used in order to provide a safe transmission of data. Secure Sockets Layer, or SSL for short, is a public encryption key protocol that is used by HTTPS to ensure security on the internet. When a web browser connects to a server that is using SSL, it will ask the server to identify itself. The server then sends back an SSL certificate, which is used to authenticate the identity of a website. Now, the client knows that the server is trustworthy and sends a message to the server, which is responded by an acknowledgement. The client can then start to transmit encrypted data to the server. Most websites now use HTTPS as their protocol even if no personal information will be transferred throughout the whole session. This is because Google will regard websites that are not SSL protected as not secure and will penalize these websites in their search rankings. These are the references that my video is based on. Thanks for listening.